Hey y'all, in this lesson, I'm going to teach you how to factor quadratics when the a value is 1. So that means that they start with x squared, not like 2x squared, 3x squared, so on. You get the point. So before we get into factoring, let's talk about what factors are. So for something to be a factor of a number, that means that that number divides by the factor. So for example, factors of 6 would be 2 and 3, 1 and 6, because all of those numbers kind of go into 6 or divide by 6. So I have a couple examples here just to kind of warm you up for factoring. What are some factors of 15 that add to 8? So the best thing to do here, 15 is pretty easy, but when numbers get bigger, it can be kind of difficult to keep track of. So let's list out these factors right here, 1 and 15, not 2. I don't know why I wrote 2. 3 and 5. And then if you go 4, 5, we're circling back around, so I can stop there. We're looking for a pair that adds to positive 8. And we can see right here that 3 and 5 multiply to positive 15, and they add to positive 8. So that's the pair we're looking for. In the next one to the right, it says factors of 15 that add to negative 8. I know I'm going to be playing with 3 and 5 because I just found in the previous example that 3 and 5 add to 8, but I'm wanting it to be a negative 8. So I need to kind of play around with the signs a little bit to make it be negative 8. If I do negative 3 and 5, that adds to 2. I can make that plus instead. If I do 3 and negative 5, that's negative 2. And there's one more option. I can do negative 3 and negative 5, and that gets me negative 8. So that's the pair I'm looking for. And you want to check it. Is negative 3 times negative 5 positive 15? Yes, it is. And negative 3 minus 5 is negative 8. Yes, it is. So we know we found the pair. Go ahead and try the 2 on the bottom. I kind of already gave you the answer, but just pause it, try it, come back. So I wrote down all the possible combinations here. 3 plus 5 is 8. 3 minus 5 is negative 2. Negative 3 plus 5 is positive 2. Negative 3 minus 5 is negative 8. And we're looking for the one that's negative 2. So the combination we need is right here. 3 and negative 5. So the last one, if we just use those same combinations, are going to be negative 3 and positive 5. And again, make sure that they multiply to the correct number and they add to the correct number. If you can do this skill, you can factor. That's how easy it is. So let's back up a little bit. Let's rewind just a little bit. And let's multiply these two binomials. Binomial means two terms. We're multiplying two binomials. There's several methods you can use to do this. One of those methods is to what they call FOIL. That's the distributive method. So you can do x times x, x times negative 3, 5 times x, 5 times negative 3. Or I like to do the box method, which is just a picture representation of the distributive method. It is the distributive method. We're just distributing. So we still have x times x, x times negative 3, 5 times x, 5 times negative 3, and we get x squared plus 5x minus 3x minus 15. And that simplifies to x squared plus 2x minus 15. So this is going to come into play in just a second. When you're factoring, you're wanting, we are starting here, and our hope is to end here. So this is called factored form. We've broken it up into two factors. In the previous examples, our factors were numbers, 3 and 5, 3 and negative 5, so on. in quadratics, your factors are usually two binomials or a monomial and a binomial or whatever. There's different ways, but this x plus 5 is a factor and this x minus 3 is a factor. And when we multiply those together, we get this. So a lot of times I have students ask, well, where did the x squared go? The x squared is just broken up. We broke it up into x times x. And then, you know, the 5x and the negative 3x and the negative 15. So it's just broken up into two different things, and that's called factored form. A trinomial in the form ax squared plus bx plus c, this is a quadratic function, can be factored, quickly using the AC method. So the AC method is you find factors of the product AC that add to B. And you might be going, what are you talking about? And I'll show you. It's really simple. So this is a product, A times C. And in this particular lesson, A is always going to be 1, because those are the examples that I gave you for this lesson. So you're going to see all the previous examples. You're going to see this come together real quick. All right, we're going to use the AC method. And then after these two examples, I'm going to show you a shortcut, and it is much faster. And the reason why we need the shortcut is because in college algebra, when you're working problems, factoring is one very small step of the entire problem, and you need to be able to do it very quickly. So I'm going to show you how to do it quickly in a second, but we're going to take the long way first. Okay, so this is A, this is B, this is C. The AC method says you multiply A times C, and you find factors of that to equal B. So factors of negative 18, we'll just consider 18 for now, are 1 and 18, 2 and 9, 3 and 6, 4, 5, 6. I've looped back around, so I'm done. Those are the only factors. And I'm looking for a pair that will add to negative 7 and multiply to negative 18. This indicates, the negative indicates that one of the factors is going to have to be negative. So when we're looking at the pair of factors, we have to consider the fact that one of them could be negative. So 1 and 18, whether I add those or subtract those, that's not going to get me to negative 7. That one's not going to work. So we're going to cross that out. 2 and 9, if I add 2 and 9, I get 11. If I subtract 2 and 9, I get 7. So this will work. And now I need to play with the numbers or the signs on the numbers to make sure that it adds to negative 7. So if I need it to add to negative 7, I need the larger number to be negative. 2 plus negative 9, and you can use your calculator for this, that's fine. 2 plus negative 9 is negative 7, and 2 times negative 9 is negative 18. So that satisfies both my conditions. I need factors of negative 18 that add to negative 7. And then we're going to rewrite our trinomial with these two new factors. So that's x squared plus 2x minus 9x minus 18. So you might be going, whoa, where did the 2x and the negative 9 at? Why are we doing this? What are we doing? Just bear with me. What we're doing is we're kind of expanding this out so that we can break it down and factor it. So if you remember, the negative 7x is the same as 2x minus 9x. 2x minus 9x. 2x minus 9x is negative 7x. So it looks different, but it's technically still the same. It still equals the same thing. So from here, there's several ways you can factor this. You can do the grouping method or you can do the box method. I prefer the box method, but if you want to use the grouping method, that's totally fine. The grouping method groups these two, you pull out a GCF, and then you factor. I feel like it can get a little bit tricky when negatives are involved, so I really prefer the box method. If you remember up here, we started with a quadratic. I'm sorry, we actually started with the factor, but if I go backwards, because I'm factoring, we start with a quadratic. We rewrite it with 4 terms. Those 4 terms live inside the box. And then these are GCFs, greatest common factors of those terms. So we've done this step, we've done this step, we're about to go to this step, the box method. And so I'm going to draw a box with 4 squares. And I'm going to put my my terms in the squares. The order doesn't matter. Really here, you can do 2x here, negative 9x here, or you can flip-flop those. It doesn't matter. And now from here, we're going to find a GCF, a greatest common factor, between the columns and the rows. So I'm going to look at the first column, and I'm trying to find something that they have in common, a factor that they have in common. So I'm going to go down here to kind of write this out. I have x squared and negative 9x. I can rewrite x squared as x times x, and I can rewrite negative 9x as negative 9 times x. What do they have in common? Do they share anything? Hopefully you can see that they share an x. So I can pull out an x. And then for 2x and negative 18, 2x is 2 times x. Negative 18 can be written as 2 times negative 9. So they share a 2. Then I'm going to go to the top row. X squared and 2x, they share an x. Negative 9 and negative 18, they share a negative 9. They're both divisible by negative 9. Now, a little shortcut here with the box method. If this first term is negative, you're going to pull out a negative. So you'll notice here, I pulled out a negative. You'll notice here, my first term was not negative, so I did not pull out a negative. Okay, that's how you do that. That's how you navigate that. So my 2 factors are, if we go back up here to this example, my 2 factors are these binomials. And that's it. That's factored. So I can write this as, I'm going to run out of room here, guys. Sorry. X plus 2 times x minus 9. You can flip-flop that if you want. It can be x minus 9, x plus 2. That's called the commutative property, where you can switch the order of multiplication and it's still the same. So either one of those answers is correct, and that's how you factor. So I want you, that was a long process. I want you to do that same process on the example to the right. Pause it, try it, come back. All right, I haven't finished completely, but I've got it started for you. The first thing you want to do is multiply a times c, and we get positive 8. We're looking for factors of 8 that add to negative 9. That pair is 1 and 8. Both need to be negative. Negative 1 minus 8 is negative 9. Negative 1 times negative 8 is positive 8. So it satisfies both conditions. So I'm going to use those 2 factors to rewrite my quadratic into 4 terms. And the 4 terms fit very nicely in this little box right here. Again, order doesn't matter. You can, this could be negative 8x, this could be negative 1x, that doesn't matter. And then you're going to pull out the GCF. So x squared and negative 8x share an x. Negative 1x and 8 don't really have anything in common. So it's going to be a 1. When they have nothing in common, it's going to be a 1. That first term is negative, so I need to pull out that negative. Then the first row, x squared and negative 1x share an x. Negative 8x and 8 share an 8. And remember that first term is negative, so I pull out a negative. So my two factors are x minus 1, x minus 8. All right, so that's kind of a long process, right? It's not terrible, but it's a little bit long. And if you're in a class where you need to factor very quickly, like algebra or calculus, then you're going to want to use a shortcut. So if you notice, I want you to pause it and try to see if maybe you can make a connection between your final answer and your factors. Pause it, think about it, come back. Basically, the binomial factors come from, so let's look at this one. The binomial factors, x minus 1, x minus 8, come from the pair we found in the AC method. If you look here, negative 1, negative 8, this was negative 1, negative 8. In the previous example, positive 2, negative 9, positive 2, negative 9. So instead of doing all this, which you can, feel free to do that all the time. Instead of doing all this, once you find your two factors, you can jump straight to factored form. So let's practice that. I have some examples down here. I said the factors come from the pair we found from the AC method. You can summarize that however you want. Whatever makes sense to you is perfectly fine. All right, in these examples down here, I've got some different variables, but they are the same thing. So in the first example, I'm using m, doesn't matter. We actually just did this one, so this is a repeat. But factors of 8 that add to negative 9 are negative 1, negative 8. So we can write that m minus 1, m minus 8. And then factors of 63 that add to negative 16. Remember, 63 comes from 1 times 63. We have 1 and 63, 3 and 21, 4, 5, 6, 7, 7 and 9. Ooh, that one will work. So that's going to be negative 7, negative 9. Those add to negative 16, multiply to positive 63, and that's factored. So I want you to try the rest of these. Actually, the bottom row I need to talk about a little bit, but go ahead and try these next 4 on your own, and then come back and check them. On the top right, you should get factors of negative 14 that add to negative 5 are positive 2 and negative 7. So we have p plus 2, p minus 7. And be careful in your homework if you write x plus 2, x minus 7, you'll get that incorrect because it is p. And then on the second row, we have some special cases. These are called perfect square trinomials. And the reason why they're called that is because we have a perfect square here and its factors add to the middle. So the factors of 25 that add to negative 10 are negative 5 and negative 5. Since we have two factors that are the exact same multiplied together, we can consolidate that to x minus 5 squared. And that would be your answer. That's a perfect square trinomial. If you think of it like x times x is x squared, it's the same type of thing. X minus 5 times itself is x minus 5 squared. And then the next one, factors of 36 that add to 12 are 6 and 6. Again, perfect square trinomial. So we consolidate that and we get x plus 6 squared. Next one is not a perfect square trinomial. Factors of 3 that add to 4 are 3 and 1. So we have x plus 3, x plus 1. Okay, and then the bottom row is something, if you toyed around with it and tried it, good for you. But it's something maybe you haven't seen. These are called the difference of squares. So all of these numbers are squared, perfect squares, x squared, 100, x squared, 49, x squared, 25. All of those are perfect squares. and they have a minus sign. So this is called the difference of squares. Difference of squares. And basically here, there's no middle term. So all of these had this middle term, and these are called trinomials. In these, there is no middle term. So technically, we could rewrite this as x squared plus 0x minus 100. So we're actually looking for factors of 100, negative 100, that add to 0. And if we look for that, there's a lot of factors of 100, but I'm going to skip to the factors that we're looking for. 10 and 10, if I make one of them negative, negative 10 plus 10 is 0. So we can write that as x minus 10, x plus 10. Now, these are not the same factors because they have different signs. So I'm not going to join them together like I did in the previous examples above. This is just done. X minus 10, x plus 10. So I have a negative factor and a positive factor. And that's your answer. So in the next one with x squared minus 49, factors of negative 49, sorry, that add 14. Where did I get 14? Sorry. Factors of negative 49 that add to 0 are negative 7 and positive 7. So we have x minus 7, x plus 7. And that's it. So go ahead and try the last one. Kind of spoiled these two for you. But try this last one. Pause it, try it, come back. You should get the two factors were negative 5 and positive 5. So you get x minus 5, x plus 5. If you switch the order, remember the commutative property means that that's okay. So if you did x plus 5, x minus 5, that's good too. There's one other example that I don't have on here that I want to show you. Let's see, x squared plus 100. So we have two perfect squares, but we have a plus sign. So I'm looking for factors of positive 100 that add to 0. And if I try to do negative 10 and positive 10 like we did above, I get negative 100. So that doesn't work. But if I keep them both positive, 10 times 10 is 100, but 10 plus 10 is 20. So that doesn't work. So this is an example of what we call prime. It does not factor. So when it doesn't factor, it's called prime, and this is completely simplified. We will learn the way to solve this later on, but for this lesson, if it's just asking you to factor it, it doesn't factor with real numbers. It does factor with imaginary numbers, but we're not going over that today. So if you come across something like that where there are no factors that exist, then you say prime. Another example would be x squared plus 5x plus 3. You're looking for factors of 3 that add to 5. The only factors of 3 are 1 and 3, and those do not add to 5. So this is also prime. Anyway, that's all I have for this lesson. I hope you enjoyed it. I hope it was helpful. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.